Hello F Sharp, and welcome back to our Intro to F Sharp series. Today we are going to talk about the option type in F Sharp. It's also known as the way that F Sharp deals with the idea of null. Now I will give a disclaimer. If you hear cute voices in the background of this recording, it is because it is Valentine's Day at my house and my children are very excited. So you have been warned, but this is the time that I have available to record. So here we go. So option type. Now, one of the things that you will probably have heard about the F Sharp language is that it disallows nulls, or it doesn't have nulls. And people make a big deal about null being a mistake. It's called the $1 billion mistake by some people. I'm an F Sharp developer, and I'm not sure I actually believe that null was a mistake. Null actually makes a lot of sense in the right context. There are certain languages like C where, yeah, you have null memory addresses. That makes sense. And in those languages, that idea is sensible, because you want to allow all kinds of crazy things because you're working at such a low level and kind of right against the hardware of the machine. F Sharp, though, is a higher level programming languages, and many of the languages that people like to work in are higher level programming languages that disallow these things that don't make sense for our domains. And if you are developing business logic or some type of computation to express some domain, you don't really need the idea of null. You don't want to have to check for null all the time. And so you'd rather have some other mechanism to represent the absence of value. And so in F Sharp, the way we represent the idea of the absence of value is with, I'm going to go ahead and move this here to the right and see. Hopefully that's going to work for me. We represent that idea with an option type. And the option type is a discriminated union. And I'll go ahead and describe how it is actually defined in F Sharp, but then I will go ahead and use it. So you can think of the option type in F Sharp. I'm going to call it my option right now. It is a generic type. It has a generic value, and it holds a value, and it has two different cases. It has the none case, and it has a sum case with the value in it. And so this is an example of a discriminated union type being a part of the core library of F Sharp. And this is essentially how the option type is defined in F Sharp. It is either a none case where there is no value associated with that case, or it is the sum case and there's a value associated with it. So this is how it's represented. I'm not actually going to use my version of it because the F Sharp language has it built in. So this is how I would define one. So say let empty value equal none. And this is just some empty value. It is an option type, but it is the none case, which means there's nothing there. Or I could have a value, and I could have, hey, it's the sum case of the option type, and I'm going to put a 1 in there. So now a value is an option type, and the generic type for it is an integer. So it is an option, which is wrapping an integer value. Now, what's interesting about this is that I can define another instance of this. So let b value equal sum of 1. And so I now have these two option types. They are both wrapping integer values, and the option type has structural equality. So if it said, hey, a value equal to b value, what would that give me? I'm going to go ahead and run this, and hopefully we get a result. Yep. So we defined a value is an integer option, and we have b value is also an integer option. They are each the sum case of the DU. And when I say, hey, is A value equal to B value? Even though these are two different references, they are evaluated. When I say, are they equal? It's going to say true. Like, yes, A value and B value are equivalent to each other. If I said A value equal to empty value, clearly that is going to be false because the A value is holding an integer and the empty value is not holding anything. And I can, if I want to work with the value inside of the option type though, like let's say like, hey, I wanted to add a value to A value. So like, okay, well, how would I do that? So I'm going to say let x1 equal to A value. And then let's say I wanted to add 1 to it. The compiler is going to say, no, you can't do this. And if we hover over it, it's going to say, hey, I require these members. The type int does not match the type int option. A value is a different type from just a plain integer. It is an option integer. It is an option which holds an integer value. So I cannot do this directly. And this is a feature. This is a good thing about F#. And this is the importance of being able to encode the absence of value. Now, if we were dealing with another language that had nulls and A value was just null, the compiler would say like, well, I mean, okay, integer is a value type, so this doesn't quite work, but we wouldn't necessarily have to check for whether it was valid to add these things together or not, because the fact if it was null or not, we wouldn't know, and it would just go ahead and try to do it, and then we get this null reference exception. Here, we're explicitly encoding the fact that there's a possibility of us having or not having a value. So if we want to work with the value the option is wrapping, we need to unpack it somehow. So this approach isn't going to work. So what we can do is something like this: match A value with, now we're going to provide a sum case handler. So if it's the sum case, we're going to have a value in there. I'm going to say, hey, V plus 1. But we have another case. An option can be a sum case or it can be a none case. So what do we want to do in the case of none? So this is how the F# compiler is forcing us to deal with the fact that, hey, there is the possibility of the absence of value. Now you could say like, oh, okay, well, I really don't know. So do I just want to have like a default of 0? Because it has to match whatever this is returning, and this is returning integer. Well, do I want it to return a 1? I don't know. And I am being forced to think about it, which is the real feature here. I need to think about my domain, and for my domain, what makes sense to do in this context. For the sake of simplicity, I'm just using integer types here. But imagine these were some types that represented your business domain. What would it mean to need to add a value to something, but that value isn't there? Like, what do you want to do with that? You need to handle that case. And this is what caused people to say like, hey, null is $1 billion mistake. Again, I don't necessarily believe that is the case. I think that null is a feature that you may or may not need in your language. And the F# language has said, hey, we want to avoid nulls. We want to make the idea of null like very difficult to represent. You can still deal with nulls in F#. It's just, it is so pushed to the side that you rarely even have to think about the idea of nulls. So this is like, okay, well, maybe this is what we want to do, where it's like, okay, well, we're going to define it this way. And so x1 is now going to take on the value of 2, because when a value has a value, we're going to add 1 to it. But when it doesn't have a value, we just want to return 0. So let's try this again. Except for x1, I'm just going to say empty match a value with, well, no, I'm not going to do a value. I'm going to do empty value. And sum v. And again, I'm going to have the exact same logic. And if none, I'm going to return 0. This is kind of clunky. Normally, we would be calling a function to do this. And I'm going to go ahead and run that. Like, okay, it's going to return 0 because the empty value is it is an option, but it is the none case. It does not have a value. So if we wanted a function for just adding 1, which probably would have been a better example of this, like let my add 1 to option. And this is going to take an option of int, and it is going to have this same logic in it. Sj with sum v plus 1, none, and then we're just going to return 0 in this case. So this is a function. It takes an option, which is wrapping an integer, and then it has a little bit of logic. In the case there's a value, it's going to add 1 to it. In the case of a none, it's going to return 0. So I can call my add 1 to option function on empty value, and I get a 0 back. And if I call it on the a value, I get a 2 back because a value is an option type and it is wrapping a value of 1. So this is an example of defining option of, in this case, just integers, but you can imagine these could also be strings. It's like, oh, my string. So now a value is a option, which is wrapping a string type. It could be anything that you want it to be, but it's really meant to represent the possibility that there may or may not be a value there for you to work with. Now, having to do this match with all the time is a little bit clunky. And I actually like to think of the option type as a collection. It is a collection which holds a single value, which seems weird, but in the future, we're going to have a video where we talk about all the very common functions that are in the collection modules. But this is such a common thing that we actually have a function for doing this. And it is called the map function. So let's work with it. So let's implement the same thing, but we're going to use a map function. So we're going to say, hey, a value, option, map, function v plus 1. And if we run this, I'm going to talk through this real quick. Now we're getting a sum 2 back. Okay, what is going on here? We have the a value. It is an option type, wrapping an integer. We now want to call the option.map function on that type. The option.map function is a higher order function, which means it takes a function as one of its parameters, and that function is a mapping function. And this is our mapping function here. We say, hey, give me whatever is inside of the option type, and I am going to perform that operation and give you an option back. And so in the case of a value, the a value is an option wrapping an integer value of 1. And so when I call this on it, it's like, okay, I have this option type. It is a sum case. There is a value in here. I'm going to take that value and add 1 to it and give you a result back. And I'm going to give you another option back. It is also a sum case, but that new option has had that operation done to it. So we've added 1 to the value that the option type was wrapping. If I call this on empty value, option.map, again, I'm going to give the exact same logic, v plus 1. What do we get back? We still get a none back. And that is because of how the map function works. What the map function does is it only calls this function when there's actually a value in your option. If there is no value in your option, it does not call this function on it. it just gives you a none back. So if you put a none in, you're going to get a none right back, the none case of the option. So it won't actually do anything. So this is actually a much more common way of working with option types, is to use the functions in the option module. I very rarely actually need to unpack the option type and doing with a match with statement. This is actually a sign. Well, I don't want to say that. If you find that you're having to match on an option type a lot, it is very likely there is a function in the option module which does what you're needing to do. And let's look at another case. So let's say if we just wanted to print out the value. So I'm going to work with a value and say, hey, match a value with some v, and then all I want to do is say, like, hey, I'm going to do a print has a value, and then print out whatever that value is. And if it's a none case, I don't need to do anything. And so this is an example of, like, we're going to take an option type. If there's something in there, I want you to actually print it out. Now let's go ahead and make this a function. Let my option printer. This would be an option int. And I'm going to go ahead and indent this. A. Oh, forgot the equals. So this is my option printer. And it's going to print out has a value if there's something actually in there. If it's a none case, then it won't actually print anything out. So I'm going to call option printer on a value. And has a value. Yay. And so what happened is we passed in our a value option. It matched on it. It said it is the sum case. And so I'm going to go ahead and call this. Now, if we do option printer on the empty value, it does not print anything out, because what happens is it matches the input value. It's the none case, and there's no logic for it to run with the none case. This is also a very common thing. Like, hey, we have something we want to do if there is actually a value in the option type, but we don't need to return anything. Neither one of these is actually returning any values. Again, this is so common. Hey, if you find yourself doing this match statement on an option type, I bet you there is a function for doing this. And in fact, there is. A value, map that into option.iter. And the option.iter function just runs a piece of code, has a value. If there's a value in there, it's going to go ahead and just run this logic, but it's not going to return anything. So this is essentially the same logic. Has a value. And we can actually take this and put this in here, call that A. So a little bit cleaner. So this is our new option printer. Call it on a value. Hey, has a value. Yay, 1. Nothing in there. So again, this is kind of an example of like, if you're needed to do something with an option type, odds are very high that the option module has a function for doing what it is that you want to do. I find that iter, it's kind of short for iterate through the values that are in that collection, and map are the two most common ones that I want to work with. Now, okay, I've kind of shown you some of the mechanics of the option type. I've kind of shown you how to unpack it. I've shown you some functions of the option module. Like, why would I need this? Why would I use this, Matthew? This seems like pretty abstract. Well, anytime you're dealing with a function that may or may not return a value, consider using an option type to represent, hey, there's a possibility that this function does not actually return a value. And a classic case is a divide. So safe divide. Let's say we have some function here. It takes an integer, takes an A, and it takes a b. These are both integers. I'm explicitly writing out the types here to make it easier for you to follow. You don't necessarily need to, but I'm going to say, hey, if b is equal to 0, then I don't want you to return a value. Because what I want to do is say, like, hey, sum a divided by b. Because what I want to do is I want to divide a by b. But if b is 0, that is not a legal operation. That is going to throw an exception. And let's go ahead and do it just for example. It's like, hey, 10 divided by 0. What happens? We get a divide by 0 exception. It is not happy. So if we are working with a domain where there's this kind of possibility, like, hey, I am going to be doing division, but there's the possibility that I have this invalid denominator, maybe I should encode that and say, like, hey, there's a possibility that this function is not able to return a value for you. And instead of just raising an exception and using like a try block or something like that, we are going to encode that in our type system, which is what this safe divide is doing. So now we have defined this safe divide function, and we are going to say, like, hey, safe divide 10 and 0. And if I call that, I'm now getting option types back. And what this function is doing is saying, like, hey, if b is equal to 0, in this domain, I don't want to throw an exception. I want to return the fact that I wasn't able to get anything. There's an absence of value now, so it's going to return the none. If b is something other than 0, then I can safely divide this, and so it's going to return a sum. So when I tried to divide by 0, it says, like, nope, I'm giving you back a none. I've encoded the fact that there's a possibility that you do not get a value back from this. And now I'm forced to deal with it as a programmer. So this is a feature. It seems annoying when you first start out. It was annoying to me, but over time, it allows you to more accurately represent your domain and be more confident that the code that you write is actually robust and correct. So I'm going to say, hey, safe divide 10 by 2, and I actually get a value back. I get a sum case for the option, and that sum is wrapping a value of 5. So again, this is kind of a silly example, but when you're modeling your domain, use the option type to encode whether, hey, this function may or may not return a value, and I need the caller to be able to deal with that fact. So this is a very, very powerful feature of the F# language and a kind of a natural extension of once you have discriminated unions, you can start encoding these realities, which is, I really love it because I feel much more confident about my code when I know I've been able to more accurately model that domain. So that's all I have for you today. Hopefully that kind of gives you some insight on how to work with the option type instead of using nulls, and an example of like being able to write a function that can return some or none. So thank you very much for spending some time with me. I hope you have a wonderful day. Thank you very much.